I think the PPT is visible to all, right? So if we talk about anthocyanin, right? Anthocyanin, that is a plant pigment, right? That is a plant pigment that exists especially in flower, right? That exists especially in flower of our plants, right? And they have different types of color. Now, today our discussion on isolation. How do we isolate, right? Anthocyanin. How do we isolate anthocyanin? And first time, from which plant we isolate anthocyanin? So anthocyanin first time, anthocyanin first time isolated from red rose, right? First time anthocyanin actually isolated from red rose, right? And it also isolated from blue corn flowers, right? So two flowers, right? One is red rose and second is blue corn flower, from which we first time extracted or which first time isolated our anthocyanin. But as per reported data, if we compare red rose and blue cornflower, right? So in red rose, it is considered in better amount, right? It means better amount of anthocyanin isolated from red rose compared to uh, your blue cornflowers, right? So now if we talk about their isolation, how do we isolate? Now the point come, how do we isolate our anthocyanin? So as per reported data, first it depend on the nature of plant source. It means if we use red rose or if we use other one plant, they may be blue corn flower, right? So then we need to use a specific method for isolation, right? But almost some methods of isolations is same, right? For example, first step, right? We separate petals from the flowers of plant or from red rose, right? After that we dry those part, right? And then we grind that and make their powder, right? So very simple. First we separate, right, petals of rose flower, right? And then we dry that for some days, right? And after that we grind and convert that into a powder like material, right? Once we convert that into a powder like material, then we start their extraction. Then we start their extraction with alcoholic hydrochloric acid, because anthocyanin is a soluble, right? Anthocyanin is a soluble, or their chloride is a soluble in our alcoholic hydrochloric acid solution, right? So we do their extraction, and you know what types of methodology we use for extraction, right? For that maximum time we use a Soxhlet apparatus. For that maximum time we use Soxhlet apparatus, right? So Soxhlet apparatus required for extraction method. Once we extract, once we extract our anthocyanin from plant source, right? Then we do their precipitation, right? How do we their precipitation? Right? We take their soluble extract. We take their soluble extract in ethanolic hydrochloric acid solution, and then we add their ether, right? And when we add their ether, you know, ether is a non-polar, right? Solvent, right? And then the precipitate of anthocyanin, the precipitate of anthocyanin form. It means we can easily separate that by filtration process. We can easily separate that by filtration process, right? Because once formed precipitate, you people know, we can easily separate that by filtration method. Then we can easily separate that by filtration method. Once we filter out that precipitate, then we can dissolve that in hydrochloric acid solution. Then we can dissolve that once again in hydrochloric solution. It means precipitate dissolved in hydrochloric dilute HCl solution, in dilute HCl solution. Then after that, because for purification we need to do reprecipitation, right? Once precipitate form, right, then we dissolve that in hydrochloric acid solution or dilute hydrochloric acid solution. After that we do their reprecipitation by adding ether, right? It means if once again we add ether, then precipitation is start, and that precipitation is called reprecipitation, right? And after reprecipitation we can do their crystallization or recrystallization with alcohol, right, having HCl, right? So alcoholic HCl we use for recrystallization of precipitate. It means that precipitate convert into crystal after some time when we put that in alcoholic HCl based solution, right? When we put that in alcoholic solution where HCl already exists, right? So then they convert into crystals of anthocyanine. Then they convert into crystals of anthocyanine, right? Now, when you do complete recrystallization process, then we can isolate our anthocyanine, because that is a mixture of anthocyanine. Then that is a mixture of anthocyanine. Now, if you want separate each one anthocyanine separately, then what types method we use? For that, we use column chromatography, right? For that, we use column chromatography. And you people already know anthocyanine is a colored compound. So in column, when we use column chromatography, so then there are different types of band for different types of anthocyanine, because a specific color for a specific anthocyanin, right? So in this way we separate or we isolate each one anthocyanin from this method, right? And if you want better identification of each one anthocyanin, then we need to use paper chromatography along with column chromatography, right? You can use paper chromatography along with column. When you take fraction, one fraction, two fraction, three fraction of your anthocyanin one by one, then you can use paper chromatography. Either that fraction is pure anthocyanin, that mixture of a pure anthocyanin, or a mixture of two anthocyanin, right? So for that you can use paper chromatography for proper isolation or for purification of your compound. So very simple method which we use for isolation of anthocyanin, right? Which we use for isolation of anthocyanin. So first point, as I already told, quercitine is also one of the important anthocyanin. It is also one of the important anthocyanin, right? So very simple. First we take plant from plant source, right? For example, you can take a rose, right, flower, and then you can separate their petals, right? And then you can dry those petals. You can put that for 2 or 3 days in dry place, right? And after that, once they dry, you can make their powder with help of grinder. Very simple, right? आपने grinder की help से पहले आपने उसके पेटल्स सेपरेट कर दिए, फिर आपने उसको ड्राई कर दिया, फिर आपने उसको क्या कर दिया, ग्राइंडर से उसका पाउडर बना दिया, राइट? जैसे आपने उसका पाउडर बनाया, then you can add their alcoholic, they may be ethanol or they may be methanol. इथेनॉल और मिथेनॉल को लेना है और थोड़ा सा उसमें क्या डाल देना है, हाइड्रोक्लोरिक एसिड डाल देना है. अब आप हाइड्रोक्लोरिक एसिड क्यों डालते हो? सो दैट उसका जो ए ग्लाइकोसाइडिक पार्ट होगा, जो उसका ए ग्लाइकोसाइडिक पार्ट होगा, क्योंकि मैंने आपको पहले ही कहा एंथोसाइनिन इज ए कॉम्बिनेशन ऑफ ग्लाइकोसाइडिक पार्ट एंड ए ग्लाइकोसाइडिक पार्ट, राइट? तो जो ए ग्लाइकोसाइडिक पार्ट होगा और जो ग्लाइकोसाइडिक पार्ट होगा वो क्या हो जाएगा, सेपरेट हो जाएगा बाय हाइड्रोलिसिस प्रोसेस, राइट? तो हाइड्रोक्लोरिक एसिड का यूज करते हैं, एल्कोहलिक हाइड्रोक्लोरिक एसिड का यूज करते हैं, एंड देन यू कैन गेट एंथोसाइनिन, राइट, इन सॉल्युबल फॉर्म. एंथोसाइनिन आपको क्या मिल जाएगा, सॉल्युबल फॉर्म में मिल जाएगा. उसके बाद देन यू नीड टू ऐड देयर ईथर, राइट। उसके बाद आपने उसमें क्या ऐड कर देना है, ईथर ऐड कर देना है। थोड़ा सा आपने उसको स्टर करना है, स्टर करना है, थोड़ा सा उसको मिक्स करना है प्रॉपरली, थोड़ा टाइम के लिए आपने सेटल डाउन होने के लिए रखना है, एंड देन यू गेट देयर प्रेसिपिटेट, राइट, ऑफ द पिगमेंट। एंथोसाइनिन का आपको प्रेसिपिटेट मिल जाएगा, राइट। तो जैसे आपको एंथोसाइनिन का प्रेसिपिटेट मिल जाएगा, देन यू नो वेरी सिंपल मेथड, फिल्ट्रेशन मेथड आज यूज करोगे और उस प्रेसिपिटेट को आप फिल्टर आउट कर दोगे, राइट। देन आपने एक बार फिल्टर कर दिया, अब उसमें कुछ इंप्योरिटी भी हो सकती है, उस इंप्योरिटी को आपने अगर क्लीन करना है, आपने अगर सेपरेट करना है, तो एक बार आप उसका रिप्रेसिपिटेशन करिए। हाउ डू वी रिप्रेसिपिटेट, राइट? वंस वी गेट प्रेसिपिटेट, then dissolve that in HCl solution, right? dilute HCl solution में आप उस प्रेसिपिटेट को क्या कर दीजिए, डिसॉल्व कर दीजिए, राइट। एक बार आपने उसको उसमें डिसॉल्व कर दिया, उसके बाद फर्दर आप उसमें क्या ऐड कर दीजिए, ईथर। एक बार वो प्रेसिपिटेट आपके HCl के सॉल्यूशन में डिसॉल्व हो जाता है, तो देन यू नीड टू ऐड, राइट, फिर आपने फिर से ईथर को ऐड करना है, एंड व्हेन यू ऐड ईथर, देन आपको फिर से क्या मिल जाएगा, प्रेसिपिटेट ऑफ पिगमेंट मिल जाएगा, राइट। तो देन वंस अगेन यू गेट प्रेसिपिटेट ऑफ द पिगमेंट, एंड दैट इज कॉल्ड रीप्रेसिपिटेशन, क्योंकि दो बार प्रेसिपिटेशन हो जाए, एक बार पहले आपने प्रेसिपिटेशन कर दिया था, एंड दूसरी बार आपने फिर से उसका क्या कर दिया, प्रेसिपिटेट। तो दिस इज कॉल्ड रीप्रेसिपिटेशन, राइट। आपने रीप्रेसिपिटेशन कर दिया, देन उसके बाद आपने क्या करना है, एल्कोहलिक जो एल्कोहलिक एसिड सॉल्यूशन था, एल्कोहल प्लस HCl का सॉल्यूशन था, उसमें उस प्रेसिपिटेट को फिर से क्या कर देना है, dissolve कर देना, right? And if you put that for a long time in a cool place, right, so then after some time you will be get crystals, right? कुछ टाइम के बाद जब आप उसको किसी ठंडे प्लेस पे रखोगे, तो वो धीरे धीरे करके उसमें जो एंथोसाइनिन होगा वो पिगमेंट क्रिस्टल्स में कन्वर्ट हो जाएगी। बट द पॉइंट इज दैट कि देयर इज नॉट ओनली वन कंपाउंड, राइट। वहां पे केवल एक एंथोसाइनिन तो नहीं होगा, देयर मे बी मोर देन वन एंथोसाइनिन कंपाउंड, राइट। तो उसके बाद इफ यू वांट सेपरेट ईच वन एंथोसाइनिन कंपाउंड सेपरेटली, बिकॉज दैट इज अ मिक्सचर ऑफ एंथोसाइनिन, राइट, दैट इज अ मिक्सचर ऑफ एंथोसाइनिन, राइट। तो आफ्टर रिक्रिस्टलाइजेशन आपने क्या करना है, उसको आइसोलेट करने के लिए कॉलम क्रोमेटोग्राफी का यूज करना है। यू नो column chromatography is very advanced method for isolation of natural product, right? तो फिर आपने कॉलम लेना है, उसमें आपने, मैंने कहा था आपको सिलिका जेल पैक कर देनी है, एंड देन उसमें आपने जो आपका रिक्रिस्टलाइज एंथोसाइनिन है उसको डाल देना है, एंड देन यू कैन यूज डिफरेंट टाइप्स ऑफ सॉल्वेंट, राइट, फॉर देयर इल्यूशन, राइट। तो उसके इल्यूशन के लिए डिफरेंट टाइप्स के सॉल्वेंट आपने यूज करने, देन वन बाय वन, बिकॉज in initial stage there are so many bands, right? initial stage में क्या होगा, वहां पे बहुत सारे bands बनेंगे, 1 2 3 4, मे बी पिंक कलर का, मे बी ब्लू कलर का, मे बी रेड कलर का, डिफरेंट टाइप्स के अगर एंथोसाइनिन होंगे तो उनके डिफरेंट टाइप्स के बैंड्स दिखाई देंगे, एंड वन बाय वन, राइट, यू कैन सेपरेट दैट, राइट। आपको एक एक करके वो जो बैंड्स होंगे, जो कलर बैंड्स होंगे, उनको फ्रैक्शंस की फॉर्म में क्या करना है, सेपरेट करना है, राइट। फर्स्ट फ्रैक्शन, सेकंड फ्रैक्शन, थर्ड फ्रैक्शन, एंड along with column chromatography, if you want, right, very if you want very good identification or very good separation or isolation, then you need to do along with column chromatography पेपर क्रोमेटोग्राफी। आपको साथ ही साथ क्या करना है, पेपर क्रोमेटोग्राफी। एक फ्रैक्शन लिया, फिर उसका पेपर क्रोमेटोग्राफी से देखा, राइट। आइदर दे गिव सिंगल स्पॉट, if they give single spot, it means your anthocyanin is pure, and if they give more than one spot, it means there are more than one natural product or more than one anthocyanin, it means that is not a pure, that is a mixture of anthocyanin। तो one by one आप जब फ्रैक्शन लोगे तो देखोगे, in maybe in first fraction only one compound, in second fraction only one compound, then third fraction there may be only one compound, four में only one compound, and fifth में two compound, it means जो आपके फर्स्ट फोर हैं उनमें क्या है, एक कंपाउंड है, देन यू कैन मिक्स ऑल फोर फ्रैक्शन टुगेदर, राइट, बिकॉज देयर इज ओनली वन एंथोसाइनिन। अब आपने जो फिफ्थ है उसमें देखा, उसमें दो स्पॉट आ रहे, इट मींस देयर इज अ मिक्सचर, then you take 6 also, 7 also, and when there is a single spot, it means now next anthocyanin come in pure form, right? तो इस तरह से आपको एक एक करके क्या करने पड़ते हैं, एंथोसाइनिन क्या करने पड़ते हैं, सेपरेट करने पड़ते हैं, एंड दिस इज अबाउट आइसोलेशन, दिस इज अबाउट आइसोलेशन ऑफ एंथोसाइनिन। So there may be question, what, how do we isolate anthocyanin. What about their procedure? So this is a procedure. And if we are, if anybody asks you about occurrence, so first time it is separated or it is isolated from red rose and blue cornflower. But as per reported data, right, better quantity or better quality of anthocyanin separated from red rose, right? Now after that, next point, after anthocyanin isolation and occurrence of anthocyanin, next important point, most one of the important anthocyanin is one of the important colorful compound is quercitine, right? That exists in bark of Quercus tincotoria, right? That separated or that first time isolated from the bark of Quercus tincotoria, right? So this is the plant from which we isolate this compound, right? Now second important thing, you people already know. First thing, because quercitine or anthocyanin, it is a combination of a glycosidic and glycosidic part. So we first separate glycosidic part from a glycosidic part, right? So actually raminose is a glycosidic part of quercitine. Raminose is a glycosidic part of quercitine, right? So after acidic hydrolysis in presence of HCl, you can see here, after acidic hydrolysis, right? So C21H20O11, this is molecular formula of quercitine, right? So you can see, right, after acidic hydrolysis, separate glycosidic part from aglycosidic part, right? So this is raminose, CH3CHOH, this is the compound, and CHO, right? So raminose will separate out, and here C15H10O7, it will separate out also, right? So this is our aglycosidic part. This is our colorful compound. Now next important point, right? How do we determine their structure, right? So after acidic hydrolysis, we separate a glycosidic part, which is our focusing point, right? Now after that, next, structural determination. How do we determine their structure? So first we use analytical method for analytical analysis, and on the basis of analytical data we clear the molecular formula of the compound or the this quercitine, right? Quercitine, this is this is actually quercitine, right? It is anthocyanin like, and this aglycosidic part, this aglycosidic part is called quercitine, right? So when we, sorry, actually this is quercitine, this is called quercitine, right? It is a combination of two things. One is a glycosidic part, and second is glycosidic part. And after their acidic hydrolysis, they convert into raminose as a glycosidic part, and quercitine is a glycosidic part. So quercitine convert into quercitine and raminose, right? Now on the basis of analytical data, we clear about number of carbon 15, number of hydrogen 10, number of oxygen 7, right? So this is on the basis of analytical data. After that, next point, right? We people already know anthocyanin or quercitine, right? Both plant pigment there, that is pentahydroxy compound. It means 5 OH group exist in our anthocyanin, either it is quercitine or anthocyanin. So then how do we confirm when they react with methanol, and then they convert into pentamethoxy compound? When they react with methanol or methyl sulfate, right? When they react with methyl sulfate or methanol, and then they convert into pentamethoxy compound, or acetic anhydride or acyl compound, then they convert into acetyl, penta-acetyl derivative, right? So because they convert into penta-acetyl derivative or pentamethoxy derivative, when they react with methyl sulfate, right, by methylation process, or by acetylation process with acetic anhydride or acyl chloride, right? So then it is confirmed there are 5 hydroxy group. There are 5 hydroxy group. It is clear there are 5 hydroxy group, right? Now after that you can see, right? After that you can see some reaction. If this is actually structure, this is actually structure of quercitine, right? Here OH, 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 and C double bond OO, right? So you can, if you think about the structure of anthocyanin, so there is not carbonyl group. at this position there is no carbonyl group, but here in quercitine, important, based on this carbonyl group we can differentiate quercitine and anthocyanine. Here carbonyl group, right? So now this is actually structure of quercitine. You can see this is actually structure of quercitine. Pentahydroxy, 1 2 3 4 5 pentahydroxy, right? And here this is ether like group, and this is carbonyl like group, right? So after their fusion with potassium hydroxide, this part will separate out and this part will separate out, same like anthocyanine, right? Two compound will separate out. First one is fluoroglucinol, right? And second photocatachoic acid, right? So photocatachoic acid and fluoroglucinol, right? Two compounds are separated, same as anthocyanine. So after their fusion with potassium hydroxide, after their fusion with potassium hydroxide, they convert into this types of compound, trihydroxy compound, and second this dihydroxy along with COH group, right? So now next one, after methylation with Me2SO4, right? Methyl sulfate, right? They convert into pentamethoxy compound. They convert into pentamethoxy compound, right? And if we react that compound with ethanolic KOH, right? So then their degradation once again, their fusion or their degradation once again, and they convert into these two compounds. First one is veretric acid, right? Where you can see OMe, and here COH, right? Same like this compound, their only difference OMe, right? And here you can see 6-hydroxy, because here this is 6-hydroxy at 6 position hydroxy group, 1 2 4 trimethoxy, because one, this is first position, so here methoxy group OMe, here OMe, and here OMe, right? So 1 2 4 trimethoxy acetophenone, because COCH2, right? So acetophenone, right? There is a acetophenone. This is a part of acetophenone, right? So 6-hydroxy 1 2 4 trimethoxy acetophenone and veretric acid, right? Separate out after this reaction, right? And if you want to synthesize this compound, agar aap is compound ko, if you want to synthesize quercetin, then you need to use, right, these types of compound. Aapko is type ke compounds ka use karna padega. It means you need to use acetophenone, right? Acetophenone like 6-hydroxy, right? You can see 6-hydroxy 1 2 4 trimethoxy, this types of compound, right? Acetophenone, right? Acetophenone. तो एक आपको एसिटोफिनोन का इस टाइप के कंपाउंड का यूज करना पड़ेगा. You need to use this types of compound, and second you need to use this types of compound, right? So they combine and then they finally convert into quercetin, right? So synthesis also you can see what about their synthesis. So compound like this 2,4 dimethoxy 6-hydroxy acetophenone, right? So here COCH2, right? We can add here OCH3 also, methoxy group, right? It depends on condition, right? Now 2,4 dimethoxy 6-hydroxy acetophenone, 2,4 dimethoxy, right? मतलब कहने का अर्थ ये होगा रिवर्स कर दो तो सिंथेसिस होगी, और अगर फॉरवर्ड कर दो तो डिग्रेडेशन होगी, राइट? तो 2,4 dimethoxy 6-hydroxy acetophenone, first we take this compound and that react with 3,4 dimethoxy benzaldehyde, right? तो यहाँ ले लिया, यहाँ पे हमने CHO ले लिया, right? So you can see, right, if these two compounds react in presence of base OH minus, right, in presence of base or OH minus, then they convert into this types of intermediate. इस तरह के intermediate में convert हो जाएगा. Simple you can see methoxy क्यों ले रहे? So that methoxy इसलिए ले लिया हमने, ये इसलिए ले लिया so that ये portion क्या हो जाएगा, protected हो गए, right? OMe बना दिया, OMe, ये 4 it means methoxy क्या होंगे, protected form में होंगे, right? ये react नहीं करेंगे, ये react नहीं करेंगे, right? And then you can see COCH3 react with CHO, and then you can see, right, here C double bond O, here CH, H2O will remove out. क्या हो जाएगा, यहाँ से H2O remove हो जाएगा, यहाँ से oxygen निकल जाएगा, right? You can see oxygen यहाँ से निकल जाएगा, H2 यहाँ से निकल जाएगा, तो ये यहाँ पे आप देखिए CH, यहाँ पे क्या रह जाएगा CS, C double bond O, CH and CS, right? So these types of intermediate will form, and when they react with HCl, right, or after that if they react with HCl, right, तो देन यू कैन सी यहाँ पे क्या हो जाएगा, ये एडिशन रिएक्शन हो जाएगी, ये यहाँ से यहाँ पे आ जाएगा ऑक्सीजन, और ये हाइड्रोजन जो है वो यहाँ पे आ जाएगा, तो दे विल कन्वर्ट इनटू दिस टाइप्स ऑफ सैचुरेटेड कंपाउंड, राइट। तो यहाँ पे CH2 आ जाएगा और ये यहाँ पे कनेक्ट, तो दिस टाइप्स ऑफ इंटरमीडिएट विल फॉर्म, राइट। इस टाइप का इंटरमीडिएट आपका बन जाएगा, राइट। So then if they react with C5H11 NO2, right, with HCl, so then they convert into that part, right, ये part जो होगा NOOC5H11, and in acid, in presence of acid, then they attack on this portion, इस portion पे वो क्या कर देगा, attack कर देगा, and then they convert into double bond NOH, then they convert into NOH, right, so double bond NOH, यहाँ पे double bond and NOH में convert हो जाएगा, then they convert into this types of compound. After that, that react with sulfuric acid and their enolization also, सल्फ्यूरिक एसिड से रिएक्शन होगी और फिर उसका इनोलाइजेशन होगा, एंड देन दे कन्वर्ट इनटू OH, राइट। एंड आफ्टर दैट इफ दे रिएक्ट विद HI, राइट, तो हाइड्रोजन आयोडाइड से जब वो रिएक्ट करेगा तो देन दे कन्वर्ट इनटू हाइड्रोजन आयोडाइड से रिएक्शन होगी, तो दे कन्वर्ट इनटू दिस टाइप्स ऑफ प्रोडक्ट, एंड दिस इज कॉल्ड क्रिस्टल, राइट। तो इस तरह से इसकी सिंथेसिस होगी, थोड़ा सा आपको प्रैक्टिस करनी पड़ेगी, बिकॉज विदाउट प्रैक्टिस नेचुरल प्रोडक्ट में पॉसिबिलिटी होती नहीं है कि आप कर पाओ, राइट। तो दिस इज द रिएक्शन, राइट, सैचुरेटेड कंपाउंड अनसैचुरेटेड कंपाउंड में कन्वर्ट हो गया, एंड दिस इज योर क्विरसिटिन, राइट। तो 3-4 स्टेप्स, राइट, इन सिंथेसिस ऑफ क्विरसिटिन, you need to do their practice also, right, and 2-3 reaction, right, how do we hydrolyze, how your quercitine convert quercitrin convert into quercetin, right. This is quercitrin, and that after hydrolyze convert into quercetin, right, and your raminuge as a glycosidic part, right. So ये चीज important है, right, and these are few reactions, there are not much more reaction, few reaction for synthesis of quercetin, right. And most important जो part है जो मैंने अभी आपको discuss किया, that is about their occurrence, right. So I already told, first time anthocyanin is isolated from red rose, right, and blue corn flowers, right. तो ये आपने note करना है, that is first time isolated from red rose and blue corn flowers से, right, in crystalline form, crystals की form में ये separate किया गया था, right, and ये देखा गया था कि red rose जो होते हैं उसमें इसका जो अमाउंट होता है और इसकी जो क्वालिटी होती है, राइट, वो कंपैरेटिवली हाई होती है एज कंपेयर टू योर ब्लू कॉर्न फ्लावर, राइट। एक तो ये इंपॉर्टेंट पॉइंट है, एंड सेकंड इंपॉर्टेंट पॉइंट जो मैंने डिस्कस किया, दैट इज अबाउट देयर आइसोलेशन, राइट, कि हाउ डू वी आइसोलेट एंथोसाइनिन और क्विरसिटिन, राइट। तो मैंने जैसे कहा, फर्स्ट इंपॉर्टेंट थिंग, द नेचर ऑफ प्लांट सोर्स इज इंपॉर्टेंट। एक तो आपको देखना है कि किस प्लांट सोर्स से आप इसे सेपरेट कर रहे हो, देन 1 by 1 स्टेप्स होगा। सबसे पहले आप प्लांट्स की जो पिटल्स होंगी उनको आप सेपरेट करोगे, देन यू नीड टू ड्राई दैट, राइट, फॉर 2 and 3 डे आप उसको ड्राई प्लेस में रखोगे सो दैट वो ड्राई हो जाए। वंस दे ड्राई देन मेक देयर पाउडर, राइट, उसका पाउडर बनाइए, फिर उसे डिसॉल्व करिए एल्कोहलिक हाइड्रोक्लोरिक एसिड में, राइट, जहां पे आपका एंथोसाइनिन क्या हो जाए, डिसॉल्व हो जाए, राइट, and that will separate from a glycosidic part also, right, glycosidic part also, right, and then you dissolve that soluble compound in a you dissolve that soluble compound with ether, right, it means उसके बाद आपने ether ऐड कर देना है, and once you add ether then the precipitate will come out, right, and then you filter that precipitate, आपने वो precipitate filter कर देना है, right, and then you dissolve that once again in HCl, and then add ether for reprecipitation, right, and then if you dissolve that at the end in alcoholic HCl, so then there is a recrystallization, आपको crystals मिलेंगे, mixture of anthocyanin का crystals मिलेगा, then you need to use a column chromatography for isolation of each one